the art. These developments have impacted our lives in a very profound manner and made packaging efficient, reliable, and user-friendly, while improving preservation of foods and other materials, waste reduction, and enhancing convenience. Research and development are the basis of all civilization, and the topic is to be seen in this context. Let me tell you also about the Knowledge Share Forum briefly, because we are partnering for the first time, and it is, I think, I'm happy to introduce the Knowledge Share Forum also to everybody. Subodh Gupta, the owner of Triveni Polymers and currently chairman of Indian Institute of Packaging. Meher Banerjee, renowned polymer technologist, formerly in Reliance, ex-president of IPI. Anjum Lakra, owner of Majora International, which is big in recycling of plastics. And he's currently joint treasurer of IPI, and I myself. We used to talk every day during the lockdown to discuss the events which were going around us and the industry and the business and so on. At some point in time, we decided that we should make better use of the time and we should try to connect with the rest of the industry. So in May, we created this forum known as Knowledge Share Forum. The idea was to keep exchanging information and knowledge, which a lot of people have, and we decided to invite outside experts and outside dignitaries to talk to us and share their knowledge and experiences with us. And some of the people have been very outstanding people, including lawyers, investment bankers, businessmen, technologists, project managers, and so on. They have come and shared their ideas on this forum. So the forum has been very active, and there has been good participation by the industry friends and colleagues. So it was only logical, and it was in the field of things that having the same goals of disseminating and sharing information, IPI and KSF should get together. So we got together to make this program possible. On behalf of IPI, the KSF, and of myself, and on behalf of Subodh Gupta, I welcome you all to the program and wish you all very good deliberations today. So welcome you all. We will be now kicking off the program as per the program. I would first like to introduce our chairman, Mr. Hariram Thakkar. He is the regional director of SCJ Group of Industries based in Bangalore. He was chairman of Indian Plastics Institute Bangalore chapter earlier. During his period as chairman, number of technical seminars and conferences were organized for the benefit of the industries. During his tenure, he did something great, which is that along with Mr. N. Sitaram, Mr. V.R. Aravamadam, and the late Mr. Prabodh Dasgupta, who was a famous and well-known packaging technologist and specialist, Diploma of Plastics Institute, DIPI course under the banner of Indian Plastics Institute was started, conducting classes on every Saturday and Sunday, which has now completed 14 years. So this is a huge contribution. He is also an active Rotarian and obviously a socialite, associated with all the southern states plastics manufacturer associations, representing Karnataka State Plastic Association and conducting IPLEX exhibitions in South India. Convener of IPLEX exhibition held in Bangalore 2015 and 2019. So he has been extremely active in the management of exhibitions as well. He has been a member of the National Executive Council Committee of Plast India. Currently, he is the chairman of Governing Council of Indian Plastics Institute. I would now request Hariram Bhai to please speak, share his thoughts with us and speak about the IPI to us. Thank you.
Thank you. Thank you, Rakesh Bhai. Good afternoon and belated Deepavali greetings to all present today. I welcome to the web panel discussion on evolution of packaging film products and technologies, jointly organized by IPI Delhi chapter and Knowledge Share Forum, as explained by Rakesh ji, under the leadership of Rakesh Sir, Chairman IPI Delhi chapter. The primary object of IPI is disseminate knowledge, which is a part of initiative of KSF also, and all are part of IPI community and stands complementary to each institution. We are aware about Sri Milind Boleji, renowned expert in film design, production and application. Welcome to you, Sri Milindji. We also have excellent personalities in this field. Sri Rakesh Sir, Chairman IPI Delhi Chapter, former MD, Windmoller and Holster India Private Limited. Great effort and initiative taken to organize today's program. Sri Sunil Ji, President Raju Engineers, a well-known figure in promoting innovative import replenishment product and guide. Our own Dr. A Sundar, ex-chairman IPI, formerly product head, Polyethylene Reliance Industries Limited, personally always available to support technical criticality, industry friendly, and under his guidance, IPI showcased Technology Pavilion in Plastivision 2020, organized by All India Plastic Manufacturers Association in January 2020. There we displayed, IPI displayed 75 innovations from various segments of the industry, such as plastic processors, additive manufacturers, machinery manufacturers, molds and die makers, and 40 numbers of posters of technical institutions. Our own Mr. Bihir Banerjee, past president, IPI, and let me wish many happy returns of the day, Bihir Babu. Now coming to the program of evolution, packaging, film production technologies. The presentation is on a very important topic. Perspective of the state of the art and future trends, development of Western film production technologies, development of machinery, and impact of development in polymer and additives, modifiers on film production. The subject related to evolution of packaging film production technologies is very much relevant and concern for the industry. And I wish everyone a good technical session this afternoon. Coming to Indian Plastic Institution, friends, it's a professional body. It projects plastics as eco-friendly material, projects the vital contribution of plastics in various fields of economy. IPI, with its headquarters in Mumbai and have 15 chapters spread pan-India and 2 overseas chapters, that is in Sri Lanka and Nepal, with more than 2,900 members at all major centers in India. Similarly, we have 22 student chapters with more than 600 student members. Our student chapter mentors have arranged regular technical lectures for student chapter members. Friends, during COVID-19 pandemic situation, all our chapters got actively involved in arranging technical presentations through IPI Zoom platform in different topics and subjects. IPI also partners with global organizations like Alan Markter Foundation, Ocean Recovery Alliance. The mission of Ocean Recovery Alliance is to reduce plastic pollution on land and water by creating strategic solutions. Prevent Waste Alliance, together for a circular economy. The Prevent Waste Alliance brings together organizations from the private sector, academia, civil society, and public institutions. We arrange regular in-house training and technical lectures, seminars, webinars, workshops, corporate learning programs, etc. on subject of topical interest for our members. IPI publishes a bi-monthly magazine with highly latest technical informations circulated freely to all our members, containing the most recent technical information and reports on major events and meetings. I invite all connected with plastics directly or otherwise should become the member of IPI. Please do visit our website www.ipiindia.org. One great thing during this lockdown period, IPI has taken the initiative to conduct the DIPI course digitally online, which has benefited students from all over the places. in the current year, people from all places are undergoing the course. IPI is founder member of Plast India Foundation, associate partners of all leading organizations, institutions. And as of today, after this program, I'm happy to inform that there is one more program being conducted by IPI Coimbatore chapter at 6 o'clock on reduce injection mold cycle time and Autodesk mold flow at 6 o'clock. Once again, I welcome all the members, participants, speakers, and friends, and wish you quality time. Take steps to stay safe. Thank you, and all the best for the today's program.
Thank you very much, Hariram Bhai. Thanks a lot. Well, we are very fortunate that Mahendra Bhai has joined us, and he's there. We can all see him. May I request Mahendra Bhai to share some nuggets of your wisdom with us briefly?
Unmute him, please.
Sorry. Thank you for the honor, Rakesh Bhai, Hariram Bhai, and everybody. I'm very happy to be here. You know, the post-COVID and this particular subject is very, very relevant because we see a definite uptick in the demand for films, of varieties of films, especially for packaging purposes, and especially for food packaging, including vacuum packaging. And it seems that vacuum packaging of the food is now rising, so to speak. And we see a great demand in the extrusion as well as the packaging machines for food packaging. So it is actually a very timely seminar to use your knowledge about the films and the extrusion to know more about the film structures, what kind of film can be used for different applications. And I think that will be very useful for the audience to listen to this. And as we see, just for the information of everybody, I'm sure everybody will agree that plastic industry seems to be, along with the automotive industry, is on a rising curve in the economy right now. And we are lucky to be there. We are happy to be there. And I'm sure we can make use of this knowledge to do even better, because we ultimately have to fight this negative image of plastic being bad. Now, how do we do that? That is going to be our next challenge. That how do we get together? How do we represent our case in a way, not using this pandemic to justify it, but using the example in order to show that plastic is not bad. It is the way we treat the waste, the way we litter. These are the things which need to be addressed. So thank you, Rakesh Bhai, and over to you. And I'm very eager to listen to the new ideas about film structure. Thank you. And thank you, Hariram Bhai.
Thank you, sir.
Very much,
Mahendra Bhai.
Thank you so very much, Mahendra Bhai, for agreeing to say something to us. Thank you very much for incisive, let's say, ideas. Now, I would like to do another of Subodhji's fillings, and that is I will now introduce Mr. Milind Bhole. He is the owner of Neil and Sid Consultants. Milind Bhole is a qualified polymer processing engineer with more than 40 years of experience in the plastic and processing and flexible packaging industry. He is today's moderator also. He is 25, for 25 years, he was involved as a professional in the conversion industry. I'm sure most of you have heard that at one time, Hitkari was the #1 company in packaging films and barrier films, and he was the man who was running it and who brought it to that position of glory. In the last 15 years, he has been working independently as a consultant for high-end packaging technologies and solutions within India and worldwide with a global customer base. His specializations involve central impression flexo printing, high barrier film production, and product development. He is holding several patents in his name for niche films, and he works very closely with some of the world's leading machine manufacturers as well as the polymer manufacturers. He has been a member of the Indian Institute of Packaging Committees and visiting faculty member. He was founder member of LPRI. Besides everything else, he's a great friend and a great philosopher and guide, and helps the entire industry with his in-depth knowledge of film production and polymer processing, as well as film formulations. Over to Milinji.
Okay, thank you, Rakesh ji, for my introduction, and I'm really overwhelmed by the compliments you have given, and I don't know whether I deserve them or not. At the same time, I must thank Mr. Hariram Thakkar and yourself for organizing this program under the banner of IPI, and thanks to Subodh ji for joining in with his knowledge sharing group. It's really an honor and pleasure for me to share some of my views on the current topics that we have on hand. Now, before I start making comments, I would like to say what is the format of today's program. So I will initiate the discussion with my opening remarks on the topic of the day. Then I will introduce the three speakers individually as their turn of speeches come. When you are going through the presentation, you are free to ask your questions, which you will put it on question and answer section. And Mihir Banerjee will be controlling the inflow of the question. At the end of three presentations, I will moderate and summary of the presentation, and we will throw open the session for question and answers. So if anybody wants to just come in, they can raise the hand, and we will see how it goes from there on. Keep your questions crisp so that we can attend to many questions as much as possible in given time. Now, when we have to start speaking about state-of-the-art technologies of today, it is always a confusing situation how to define state-of-the-art technologies, because at any given point of time, the technology that you are looking at is always a state-of-the-art technology, which may not be state-of-the-art technology 3 years or 5 years down the line, because there is always an upgradation that is happening in the technology, and there is never end to it. So when we are reviewing state-of-the-art technologies of today, we are referring to the technologies that are commercially or technically available in the market and being commercialized. So when I'm going to make the comments, my viewpoint is that I will keep on mind that what are the technologies which are going to make impact, and they are here to stay for foreseeable future, because new technologies, some of them have very short life cycle, and we must look into the technologies which has a little longer time span, because for investors and industry, now the longevity of technology is quite relevant. So today's topic, evaluation of packaging and technologies, which is one of the most relevant subjects, as Hariramji also said, which need to be discussed under current situation and circumstances which prevail now in India and globally. So I would like to make some of my comments about state-of-the-art commercial extrusion technologies that are being made popular globally, and where does India stand with reference to this global scenario, and why we need to look at technical scenario in the world, and what are its implications for us in India. Though I firmly believe that every region's cultural base, demographic pressures, and the dietary habits always drive the investments in packaging technology. But since India is now on the path of becoming a global power or export-oriented packaging industry, we need to look at what are the emerging technologies globally that are coming and its implications we have in Indian market, and how do we gear up to enhance our export base in packaging. That is why it is very important that we see the global scenario of state-of-the-art technology. Now, at this moment, India is going through a very rapid globalization, upgradation of technologies, as per the new policies of government, where India wants to become Atmanirbhar, which also means that modern technologies available in the world need to be adopted under Indian conditions to suit the local conditions, make them commercially and technically viable and also successful. What we have to also watch out now is the industry for automation and artificial intelligence that is also entering into manufacturing processes for film manufacturing. And a thorough technical audit is required out of these technologies. What are the technologies which are relevant to Indian? Should India adopt to such very high-end technologies? And what are its benefits, pluses and minuses? That review is becoming more and more critical, my point of view. I believe that India is ready for such quantum leap since the market dynamics and its drivers demand such investment, which should be in line with the changes in the lifestyle that is going on in India, the growth parameters, and the impact of pandemic, which is going to lead towards more packaged food, more package attempts, improvement in hygiene levels, leading to more demand for hygienic products and healthcare segments, which are going to grow. As these segments and manufacturing base, which is also going to grow, obviously it is going to lead to a requirement of more sophisticated, specialized packaging films, which will meet the challenges not only for domestic this thing, but since pharma and food industry now exports a lot, it will have to meet the global quality norms and performance criteria. The Indian companies now have a lot of strong technical bases in India, and everybody is looking out for further growth. And that is why today I'm going to make some comments of the critical new film technologies, which are very relevant for the future of Indian market. Now, if we have to play any dominant role in the global market, then it is very important that we adopt to these new emerging global technologies, its standards, and the quality norms. Now, if we have to come out with the standards of quality and the technical functionality of the film requirement, it is needless to say that latest state-of-the-art technologies play a very, very critical role to achieve this goal. So in short, I would say that we have to meet the global requirements of domestic markets, of delivering the product of highest quality at the most optimum cost in the shortest possible time. So from application development to film development to conceptualizing the whole project and making it commercialized, there is a lot of teamwork that will be involved. So now you have to do that, what we need to do. So let's first look at what are the technology trends that we are looking at when we talk of state of the film production technology. Now, the most dominating route that most of the Indian packaging companies are using at this point of time is basically the multi-layer co-extrusion blown films as far as the film manufacturing is concerned. And our presence in the cast film segment is quite miserable, let's put it, compared to the global norms. And we'll look at it, the pros and cons of that area. But if you look at the global scenario, I would say that the global markets are now maturing with 5 different technologies of film production of relevance, which are state-of-the-art technologies and the future of packaging worldwide. The 5 technologies that I'm talking about are basically classified as 5 process-oriented technologies status, and I'm now going to get into individual details of what are those technologies, right? So the 5 critical technologies in film production are multi-layer blown films, second, cast films, Third, downward extrusion with water quenching. Fourth, MDO. And the fifth emerging technology is blown hot melt extrusion technology. So let's look into individual technology spectrum and what are the features of today that makes them state of the art. Now, if you see the Indian industry scenario, most of the modern technologies have entered India in co-extrusion, and India has developed a good base of manufacturing blown film right up to 9-layer structure. What we are lacking in India at this point of time is adaptation of real benefits of 9-layer technology, because we lack expertise of development of new structure, understanding the new developments of polymers and how this polymer technology can be employed on this new generation multi-layer line to get the benefits of for which they are designed. Now, global market has moved up to 11 layers, and we need to understand what each additional layer means and what is the contribution of each layer into a film structure. And that understanding needs to be required. Now, new generation state-of-the-art technologies allow us to manufacture film, which each layer now going down up to 2-micron levels. Now, when you compare it with the normal or ordinary technologies, then you have constraints of individual layer thicknesses. Thereby, you have constraint what are the total thickness you can down gauge as the number of layers increases. So that is the main differentiation which comes from the new generation die technology that has enabled to handle more and more complicated polymers. At the same time, you are able to down gauge. I would say 5 years ago, the minimum thickness requirement used to be around 5 to 6 micron. Now in 5 years span, it has gone down to 2 or 3 micron level. What it means that what film you require to be made around 100 micron now can be made in 50 micron, having similar property profiles. And this comes from the design improvement that has happened in the die sector. If you see the higher end of the technology that has come on the market is automation level. Now, for example, recently technology is launched in the market where any problem happening while you are producing the film, the bubble break, etc., is noted by the machine stops itself and take over automatic control, where production will start without intervention of an operator. So right from making a bubble, adjusting the weight, segregating the wave, and again diverting it to the two sides of the winder is fully automated. And this kind of changeovers can be done in less than 10 minutes. Now, this kind of technology helps you in making the quality of the film very consistent, because since there is no transition period or settling down of pressure process parameters, again the film you start making again is of a commercial correct technical specification within the shortest span of time. Now, the new generation softwares and controls which have come, which are continuously 24/7 monitoring the diagnostic performance of the extrusion process. So if any deviation or the trends are not in line with the parameters you set, the machine will intervene and it will send you the alarm to the requisite authority to look into the production process and make the corrections. And in certain parameters, the machine itself will do the correction. Now, it helps you in two ways. Our dependence on the skills of operators is reducing, because more and more machines are coming to our country, but we don't have such a trained manpower or number of experts available who can handle this situation. So these kind of technologies can meet the shortage of manpower that we have. The latest launch of technology, which is the mobile-based app for controlling your extrusion machine. So you can be anywhere in the world, but you can monitor your multi-layer lines from any corner of the world. And not only monitor, you can get the data what you want, you can get the MIS what you want, you can do your planning, and this is very easily possible with the mobile apps which are linked to your machines. Another good development is the high output machine. Now, high output is a very simplistic term, but why there were constraints of getting outputs higher was first the cooling technology available on the blown machine, and also the die distribution, layer distribution, where die geometry was playing a very important role. The new generation of extrusion screws that have come also contribute a lot in increasing the outputs, because the rheological parameters that you match of the new material make the flows more streamlined, and that's why your extrusion is more stabilized and allows you to increase your outputs. Because the same machine which was giving earlier, say 500 kg per hour output, with this just even retrofitting this new features, you can take the machine to 800 kg per hour. So see the technical benefits you achieve and the technology bringing down the cost of production. It is a very, very important parameter. The high-end films, where you don't need any contamination and excellent optical properties, the air cages that are come up where the film bubble moves without any contact to any supporting structure also has added to the optical properties of the machine. So these are what I call state-of-the-art technologies which are emerging, and they are here to stay, and India should look at these technologies for our future investment. The second segment is cast line. The main problem in the cast line was adjusting the width of the running weight and the thickness profile. In both these sectors, now the latest technology is fully computer control, and the die is set by the computer for thickness profile. Earlier, the 2 meter, 3 meter wide dies were set with the nut and bolt by the operator. So it used to be a couple of hours operation, so huge wastages, and also the uniformity was always the challenge. New generation technology is allowing you the computer setting the die profile, which is one of the biggest breakthrough of last 3 to 4 years. Another new technology which is on the market is how do you reduce the wastage of the cast film, and particularly the barrier film, because materials are expensive and cast film do need a substantially broad trim. So the Airstream Encapsulation technology not only allows you to reduce the width of the trim, but also online you can recirculate and reuse the same material. Thereby your wastage factors are dropped by in double digits, and the film consistency is far too better. The new generation winders, which are absolutely new breakthroughs of the last year, where winders have reached winding speeds of 800 meters per minute. So though earlier the extruders had huge capacity, melt capacity or extrusion capacity, winders were the limitation. So the new generation winder with 800 meters per winding speed can cope up with the throughput, and you can enhance your productivity of cast film, making them more viable. As I mentioned in the blown film segment, the remote diagnostic and control web-based or mobile-based applications are also helping improvements of productivity and the performance and the management control. Castfilm has made huge progress on wider widths. Now, even you can get 9 meter is a standard width now, and there are films which have gone even up to 27-meter width of film. So you can imagine the sophistication of technology that must have gone into development of such a machine. Now let's look at the downward extrusion with water quenching. This is a major development that has happened in this decade, because blown films were never able to compete with cast film or certain segments where high optical films or highly transparent film with absolute absolutely perfect gauge profile and mechanical strength combination was not achievable. Plus, thickness was a big constraint. The new downward extrusion technology, which is launched by more than three companies in the world now with the water quenching, not only allows you to get an excellent clarity, but the most important factor is making a flat asymmetrical film. And that is a game changer because asymmetrical films are going to make inroad into lot many food packaging applications and mainly thermoformable waves, whether they are leads or thermoformable trays, or even it is going to hit the lamination industry big time because when you have polypropylene or a nylon in the outer layer, you don't need any more nylon, polyesters or BOPP as a non-heat resistance material. So the future is towards this technology because it is going to create new market segment and also going to replace laminates in many segments. Another factor is since it's a downward extrusion, it opens up wider flexibility of using material because you can now use even 4-5 MFI material in this technology because it's a downward extrusion. Earlier, we were restricted in upward blown film with the MFI constraints and thereby a narrow band of materials you could use. This technology has opened up bigger gamut of polymer that you can use. Another facility that is added last year is the annealing capability on this technology. So by doing the annealing of the film produced, it completely alters the processes and you can customize the properties by controlling the annealing processes. And this is another feature which will help you in creating market leadership and very dedicated specialized applications. Coming to the fourth segment, MDO. This is one of the fastest growing technology that has come to the market where you manufacture the film, blown film on a conventional blown film line. And in the same pass, it goes to the additional station called machine direction orientation process. This technology allows you to not only down gauge the film, but also it enhances the optical properties, it enhances the stiffness, and research shown recently that it enhances the barrier properties or the MVTR and other properties of the film. This is going to change the way films are used in foreseeable future, but there is a lot of research and developments are still required. It is extremely high-end niche market. India is still not ready, so a lot of research will be required, but a technology to watch for is my opinion. Pandemic has suddenly made another technology popular, which is the blown hot melt extrusion technology, which essentially suitable for hygiene and medical field. Actually, Chinese companies dominated this technology, but I also know now Indian companies have entered, and I'm sure Sunil will be talking about it a little later. But why I would like to mention this technology, because of the pandemic fear, hygiene and medical market is going to stay here in a growth mode for foreseeable future, where this technology is going to make a big inroad. And I also see that industrial applications will be emerging out of this technology. It is little innovative mind and different way of mindset, which will create a lot of new applications. And my personal feeling is India will dominate this new development because we always think differently and crazily than the more methodological scientific world of Western technology. So having said that, this is the overall review of what are the new evolving technologies in the film processing industry. So that is why it is more and more relevant that we should explore such technologies which are going to be future trends and absolute requirement of this market. What I see in India is that most of the manufacturer or converters do not work in tandem. What I mean by that is that the development of any application absorbing such state-of-art technologies worldwide, it is important that converter works with raw material manufacturer, packaging machinery manufacturer, and actual end user. For any new product development and absorption of new technologies, whether they are coming from raw material, machinery, or the packaging system, these four teams will have to come together and work together for future success of such technologies in India. So I feel India is ready to have the mindset change required to meet the challenges and adoption of such state-of-the-art technologies for India. And with this, my remark, I would like to move on to the next session. Rakesh, would you like to pitch in with some comment?
No, you go ahead. I think we go ahead with the program because I think program time is running out.
Okay, fine. So let me have the pleasure of now introducing Rakesh Shah, which actually doesn't need any introduction. Rakesh Shah is a veteran of packaging industry with more than 5 decades of experience, out of which 31 years of experience is from hardcore packaging industry. He has been managing director of Windmuller and Hostler Germany, the world leading technology and machinery provider to the global industry in field of film production. And he's the guy who is responsible for transferring many state-of-the-art technologies in film production to India. So nobody knows better than him about the Indian market and film processing technologies, which are state-of-the-art in the Western world, which will have relevance to India. So Rakeshji will give his presentation now on the latest trends in Western technologies and relevance to India. Rakesh,
Milind,
over to you.
Milind, one question is for you.
Yeah.
You like to respond now or afterwards?
I think we complete the presentations and then we'll address all questions simultaneously. Okay. So the tempo will remain.
Okay, fine.
Yeah.
Fine.
Okay, Rakeshji, stage is yours.
Okay, thank you very much. Friends, I think Mr. Bole has already given a fantastic overview of the state-of-the-art film production and the trends that are creating the future. New challenges will keep springing up, just like now the COVID has sprung up this new technology, mind-blown technology. And I think new solutions will also keep coming up. So having said that, and because he has already covered a lot of developments which have happened recently and are currently going on, I would like to straight away hit the road on of development. Much of it is already covered in his remarks. So I would briefly touch upon where we started and where we are. So let's say that when I started the work of Windmuller in India, at that time, or in fact before that, when I was with Loya and I was manufacturing and selling the tape stretching lines and woven sack machinery, we came up with technologies from Austria and from Windmuller. And when we were going to the market, because now I will focus more on the adoption because the technology side is well covered by Milinji. So, the customers used to tell me, okay, we would go and explain the technologies to them, and then they would say, okay, so your screws are made of special materials, and you've got bimetal barrels, and this and that, and blah, blah, blah. But what does it do for me? And nobody pays me 1 paisa extra. And at that time, it was pretty hard to convince them that nobody has to pay them an extra paisa. Maybe they can save another paisa, while they also make money because the technologies are reaching a point where it is no longer sensible to continue with the power guzzling machines, which produce a lot of waste and require a lot of manpower and then produce a lot of rejects. So that is how I think India began to change. And then a time came when one of the customers who had said something like that to me, that, okay, they may be made of gold, your machines may be made of gold, but nobody pays me a penny extra. He was telling my representative in Ahmedabad that please get my delivery. Just, price is Rakesh's price, but get me the delivery. So that is the power of technology, and that is the way India has changed. That is how the mindset of Indian customer has changed over the time. But let me, since that is my subject or topic, having a little bit left still to talk about how things change, let me show you a few pictures, first of all, so that this will show you exactly how do I share the screen. I don't know. Can somebody help me with sharing the screen?
So below is share screen is
Below green color
color.
you see share screen.
Okay. Can you see me? Can you see the screen?
Yes.
Okay, so
You can see the screen.
just show you 3 or 4 pictures, how it was and how it is now. And for some students who may be joining, this is how blown film line looks. An extruder, an air ring or a die. There's a die, then air ring and stabilizing cage, a collapsing frame. The film is produced like a bubble, like a tube, and then is wound. Now, this is a blown film line. This is another blown film line from the medieval ages, which was something like the late 50s or early 60s, or could be even early 70s. And this is a modern blown film line. So you can see how the development has happened. Now, this is a short video. I'll just show you very briefly. So this is a cage that Milind was talking about. And this is how, an upside down line these days looks, which he mentioned. This is a typical PP TQ line, and these were very commonly used in India, and I think they're still on the market. And they were very, very popular with the packaging of saris and many other commodities, and because of the clarity of PP. And now, where you see the extruder, they are actually extruding downwards, and you see here is a die. And this is the downward extrusion picture that you can see here. So I'll show you just another video very briefly. This is coming down from here. This is the machine is now picking up the film and maybe annealing here. And then it goes into winding. So I will not show you the other video because it's about the same. These videos were taken from a customer's place. Similarly, talking of developments, a winder that could look like that today looks like this. So you can see how big a difference it is. And in the cast film lines, there are major differences now. You see, like Milind mentioned about trying to increase the usable width and reducing the neck in. So here is a device which is electrostatic cleaning, which helps to widen the available film width on from the extruder. Because of the neck in, you lose some. And the changes in the dies, you see this is an external deckling die and an internal deckling die. And today the dies are there which are completely touchless. You can change the new dies from Chlorine company are actually such that you don't have to touch them when you make the job change, and everything can be done automatically. So, these are some of the things which I wanted to share with you so that you can get a kind of feeling as to what has changed. Now, going back to some more developments, I'll be very brief because I think we are out of time a little bit. But I'll try and cover a few things which might be of interest. You see, what were the challenges? The challenge was when the extrusion lines came around in 1950s, late 50s, the biggest challenge was to increase the productivity of the machines. So what did you do? I mean, you had to somehow increase the productivity. The extruders had the power. They could push out a lot of material, but it was not going because the material has to cool. So the cooling started, and then eventually people found a way to cool the bubbles internally so that they supply cold air. And then the cooling was further improved by having on the outside cooling, new systems, something like dual lip and triple lip for the external bubble cooling, so that with less amount of air, you could do greater amount of cooling, and you could then help the extruder output to be utilized in a full way. Screw designs already Milind touched upon. You see, in the old time, there were screws which were directed towards individual materials. And if you change a material from HTP, PPP, whatever, LDP, you had to change the screws and there's a lot of wastage of time as well as material. So eventually universal screws came in, and today I think it is more or less industry standard that everybody uses universal screws. And the material can be, most of the materials can be processed by given screws, but of course, it doesn't mean that the specific screws are dead. For very high and very sensitive applications, they are still screws designed for individual materials and they are still being used. So not to be mistaken, just to clarify that the technology is at a point where the screws can do a lot of things, but when you are in the critical areas, you may want, if you want, you can have also a screw designed for individual materials. Quality improvement was the next issue because you cannot afford, I mean, this is money, 75 to 85% of the cost of the film is actually material. So, and if you have bad material, if you have bad quality or rejections, you lost money. So the first thing was how to check the film. So film gauging was important. And then usually now currently there are many types of gauges, but on the blown and cast film lines, usually three kinds of gauges are being used, called capacitive, radiometric, and infrared gauges. And the gauges could be rotating or flat. This depends on what kind of film you're doing. So now the gauging has reached a point where you can actually have online running gauging and you can apply controls via the gauge. And the next point was, if you make a film, then I think what is most important is what is the minimum thickness of the film. And in India, we had this custom that people used to measure something like 30 or 40 feet of film. They would just make a packet and put it on a weighing balance and say, oh, this is the average running weight or per square meter weight. The film is good, but that is not the truth, because I found myself that you could find variations of up to 25 or 30% in the thickness of the film along the length or the width. So actually what you had a film which was bound to fail, because if you require a certain minimum thickness for a certain application and for a certain preservation, you don't get it because you don't realize it. So it became very important to apply some control on the gauge of the film, which means thickness of the film. So the first automation was introduced by late 80s. I think it was in 1989 that the first gauge control automation came on the market. Eventually, weight per square meter controls and gravimetric feeding began to replace volumetric feeding. In fact, volumetric feeding was itself a major step from manual feeding, and mixing was always a very big issue, and therefore they introduced cyclone mixers after the feeders. The next point was that you had a lot of difficulties with the film because film was hot when it went up and when it was wound, and it would block, so you could not open the film. So then the cooled nips were introduced, where cold water was running through the nip rolls, and you could now produce a lot more film without blocking, and you have another issue solved. The important thing after that was winding. Winding was always a major issue because, and it has been until recently also, and even today you may find sometimes on certain machines that the winding is not good and you have telescoping, you have hoops, rings, and things like that. So this happens largely because of two reasons. One is that the film is not aligned to the winder, and the second is that the film thickness is not uniform, and when it's wound, it makes hoops. So to distribute the thicknesses, they introduced what might be called tolerance randomization, which means spread the tolerance across the width of the roll. So people tried rotating platforms on which extruders were mounted and die was mounted, but this was obviously a very cumbersome system and a very heavy weight to be carried all the time, all around. And there are other physical phenomena like slipstick and various problems attached to weight and lubrication and fatigue of components and so on. So oscillating nips were invented, and initially vertical nips came up, which were very popular, but for wide width, especially beyond 900 millimeters, they were probably practically not workable. And therefore, horizontal nips came into existence, and they have since been more or less the industry standard. In the winding also, a variety of windings, because people found that PP films on storage shrink and they can crush the core. and you can have a lot of poops and rings, and you have wastage of film, and you may waste tons of films just during the storage. Similarly, you might have sticky films which will stick together if they are wound at a certain pressure, and therefore you could not always do surface winding. So gap winding and center winding systems were invented, and the winding systems completely changed. And as I showed you in those pictures, the winder that looked on the left and how the winders look today are so completely different that you can see how a development has happened. In the custom lines, already Milind told you certain features that have been introduced. I also told you about the touchless dies. And another very important thing that happened is, the die correction. The automatic die correction was introduced, and a Belgian company at that time began to introduce oil-heated bolts. And this was not a very, very good idea, because this was a lot of maintenance and as you can imagine, and the response was slow. And therefore direct bolt heating also came in, and this helped the die correction, automatic die correction, in a very big way. Eventually it was found that the hoops are still not gone, because you don't have the facility of oscillating hollow for something like that on a custom line. And then therefore the gauging was used to overcome this problem. And when the machine anticipated a thick spot somewhere, it would over adjust the bolt at that point, and therefore automatic die would, in this case, provide you finally a perfect roll. Similarly, in bubble control and sizing cages, a lot of changes happened, from steel bars to control or to guide the bubble. Teflon beads came in, Teflon rollers came in. Eventually now, I think more or less the industry standard is becoming the CRP rollers, because they are bad conductors and they don't cause sag in the film, and they also are not heavy and they're easy to roll, and therefore even relatively thin and sensitive films can still be run. And for sticky films, as Mendel also told you already, you have air-assisted pads which for contactless conveying of the film to the cage. For material saving, which is, as I said, which is the biggest single cost, I think gauge control was one thing which I mentioned already. The other was, because there used to be fairly large edge trims which was waste, and they had to be recycled or wasted depending on what material it was. So width control automation came in, and width control automation today stands at a level where you can control the width of the bubble to within plus minus 1 millimeter. So I think this is already a huge step and a development which helps people to eliminate the edge trims and therefore a lot of waste. And splicing at full speed eliminates also the slowing down of the machines or something like that. And you can and turret winders, they help you to do that you can continuously run the machines, as Milind said, up to 800 millimeters per minute, 800 meters per minute. On the custom lines, pinning I already mentioned to you for neck reduction. Besides this edge and encapsulation has already been explained by Milind. There are other measures to try to use the larger width and reduce the neck-in loss, which could be done by adjusting or over-adjusting dies at the two ends. So, but with the new dies, this is not so much normally done. Coming to the final step today, Internet of Things, and eventually Industry 4.0 has started creeping into packaging industry also, and especially in extrusion machinery. And a leading German company has already introduced on some of their machines the IoT systems. And IoT systems are actually, as a matter of fact, the companies are already started introducing as far back as early 80s systems called ISPs, or international or information systems for production. And it was already becoming possible to capture a lot of data, but it was not sufficient. And then you see the SCADA devices, and after that, now today we are standing at a point where machines must talk to each other, and that is going to happen through IoT. And that is the final step towards Industry 4.0, and manufacturing execution systems. So eventually we will move towards that. And I think we are already at the threshold when this has begun to happen. And therefore, I think very exciting future awaits us. And India has responded exceedingly well to the developments in, the country where we always heard about technologies for India and so on, and which was a subterfuge or some kind of excuse for buying cheaper materials or cheaper machines, has changed a lot. And today we are looking for the best of the technologies because we have understood very well and we have fully adopted the idea that the technology is actually paying for itself, and technology makes us more competitive. It makes us future proof. It makes us obsolescence proof, and it makes us successful. Thank you very much.
Thank you, Rakesh, for your overall review. Mihir, if you want to ask a few questions, we can have a few questions before I hand over the session to Sunil.
There is one question, Milind, for you. That is one for Mr. Atin Chaudhary. He was ex-Huhtamaki. Little more on the, he wants to know a little more about annealing with specific example to change property of thermoplastic film.
Okay, it's a good question. What happens when you make any blown film? Because of the uneven cooling and various process parameters, the properties are not balanced. So I'll just give quickly two examples how annealing can alter the property. Now, there are two problems in the blown film. If you make asymmetrical film, then obviously there is going to be curling. So by doing the annealing, you can make the film flat. And this is more relevant when you are making, say, 200 micron plus film and asymmetric. So annealing will make the film flat. Second example is that since you make multi-layer film, these films have a problem when they go on FFS machine and different layers shrink differently. There is a lot of stress inbuilt at the interlayer boundary. So by doing annealing, you can reduce the stress so that there is no shrinkage on the application machine. So these are the two typical examples I can give you, but there are many more technical aspects and benefits how you can change the properties. Yes, Mihir?
No more question now, it's there.
Okay. Okay. I have the pleasure of now introducing Sunil Jain, who is basically a mechanical engineer, and he is one of the very unique experts in India, where he has a hardcore experience of 40 years, which is equally distributed as a converter and also machine manufacturer. So he knows each and every aspect of flexible packaging with hands-on experience. He is now the executive director of Raju Engineers, which is one of the leading manufacturers of plastic blown film machines and other machineries, having presence in more than 60 countries. He has traveled globally extensively, and he knows what is the technology levels and the industry standards in Western world versus what is in India. So I would request Sunil to speak on development of machinery for film extrusion in India and relevance to Indian condition. Over to you, Sunil.
Thank you, Milind. Good afternoon and good evening, everyone. Very difficult task Milind has given me, especially when Milind is the moderator and my mentor and elder brother, Mr. Rakesh Shah, has given an overview. There's not much for me to say. I'd only like to add that whatever has happened in Europe and in the world, India has followed it right from the beginning, especially in the blown film extrusion. Going back in 1980s, monolayer was the order of the day, mostly for shopping bags and also for downward extrusion. What I'll only try to do is give you a flavor of the way the technology has moved in India based on the applications and also what is specific to the Indian industry. So monolayer plants were being made, leading machinery manufacturers with very few, Cabra, Windsor. Mahendra Bhai's respected father brought Windsor into the country. They were making the monolayer blown film lines. And there used to be a company called Kali Mata, who was still there. And later on in 1990, we at Raju Engineers also started making these machines. And now monolayer plants has become more of a, if I may say, Anand Parbat product, which is become a backyard situation. But still, there are specific applications in monolayer which are still made by the leading manufacturers. For example, we ourselves at Raju Engineers supplied a 3-meter wide, 700 kgs per hour monolayer film plant to UK a couple of years back. And specifically, some of the products are also related to stretch film. So monolayer still exists in a technology advanced version as compared to the monolayer plants being made for shopping bags. Then in two-layer, Windsor came up with the two-layer machine in 1990, and later on started with three-layer as well. That was a time when many imported three-layer plants came into the country from Kiefel, Barmac, and some from Taiwan. In 1995, nearly all the Indian companies, whether it was Cabra, Windsor, Mamta, and Raju, were offering three-layer, three-extruder, three-layer ABC kind of blown film plants. At that point in time, the output were ranging from 100 to 150 kgs per hour, and small widths about 1 meter to 1600 mm. And applications were primarily lamination grade films, and then slowly milk packaging came in. Milk is a product which has created a revolution in liquid packaging in India, and it's an example as far as the world also goes. Tetra Pak tried very hard to come to India for milk packaging, but we Indians have very strange habits. When we get milk in the morning, the first thing we do is we boil the milk. So you don't need a high barrier film. And that's where milk packaging became very big, coupled in with the the white revolution by Amul. So liquid milk packaging became very big business and became one of the largest applications for blown film in India. Very unlike what was happening in the West. In fact, milk packaging in polythene bags is something which India gave to the world. The second thing which India gave to the world was packaging of edible oil in polythene. Earlier, they used to be simple three-layer films, 120, 140 microns, short shelf life situations. So these two products, milk packaging and edible oil packaging, is a gift by the Indian industry to the world. And as Milind rightly mentioned, because of dietary habits, as I mentioned, milk packaging, very short shelf life situations, and edible oil packaging as well. Then came the advent of small packs. Another gift which India gave to the world in multi-layer packaging was one rupee packs of pan masala. That created a huge demand for lamination grade films. Talking about milk and edible oil, later on, higher shelf life situation came in. From 3-layer, it graduated to 5-layer and 7-layer and 9-layer. So demand for blown film increased. The output levels increased from 200 kgs per hour to 400 kgs per hour, and widths from 1600 mm to 2200 mm and now to 3 meters. As Rakeshji also mentioned, cooling had to be increased. There was enough throughput coming in from the extruders, but cooling had to be increased. And dual lip, triple lip, duo air wings, which are also offered in the country today. Oscillating Holoff was also mentioned, oscillating nips. It was patented by WNH, and I think it was in 1990 that the patent expired. And you have everyone in the world coming up with oscillating Holoff. And I'm proud that way back in the year 2000, Raju was the first company to come up with oscillating Holoff in the country. Rakeshji talked about rollers, yes, carbon fiber rollers. In addition to being, they are very light, so they reduce friction, and they definitely help in improving the gauge control. Width control, again, today everyone is offering it. Earlier, it was only through internal bubble cooling, which works on the basic principle of width control, and later on width measurement and width control, bringing down your width tolerance to within plus minus 2 mm. Then there was a time when that was a time when companies like Windmoller, Reifenhauser, and Markey started bringing in blown film lines into the country. The Indian OEMs started to tie up technologically with foreign manufacturers. Windsor tied up with Pune in Germany, Cabra with Gloucester, Mamta with Brampton, and Raju with Alpine. This created a new wave of high output, highly automated lines coming into the country with latest technologies. But a word of caution here, when people tied up with these foreign manufacturers, we found, at least we found in Raju, we were not getting the latest technologies. The technologies which were becoming, let's say, a 5-year-olds or 7-year-old, those were the technologies which were being given. And people in India were happy uh, to the extent that at least they were getting some high level technology at affordable price levels. Um, as I mentioned, market for laminates developed, and as Milind was mentioning, the thicknesses started coming down. People were talking about 15 to 16 micron of film being necessary as a laminate for even pan parag applications, and then going up to as uh, as thick as 200 microns for packing of atta, for example, or grains or rice, to be laminated with BOPP, foil, CPP, or BOPA. Higher output levels and lower gauge variation necessitated need for automation. Volumetric dosing, gravimetric dosing, central conveying, uh, GSM control, automatic gauge control. Rakesh ji mentioned about capacitive and nuclear sensors, and now there are systems available which even are available from Indian OEMs of measuring each layer of the 5-layer or 7-layer film. And definitely then process control, talked about Internet of Things and Industry 4. It became very, very important when you're running such high output levels. You don't want to be too operator dependent. So process control became very important. You had total machine being operated from a single or a double touch screen. Winders, yes, whether it is surface, center, or gap, going up to even 1200 mm diameter, one-ton rolls are being offered by the Indian manufacturers today. Somewhere in 2010, this is an aberration in the sense that demand for shopping bags increased phenomenally, both for the domestic industry and for exports. So calcium carbonate as a filler started to be used, which gave birth to a low-cost 3-layer plant by using an ABA configuration where you have maybe 70-80% calcium carbonate in the middle layer, and then you have skill layers. And very interestingly, this was introduced by a less known company in that point in time, a company called Shubham in Ahmedabad, which also has become a player in multi-layer segment today. To give you an overview of the market, um, all the Indian manufacturers together uh, produce about 130 blown film plants, multi-layer blown film plants. I'm talking about 3-layer and upwards uh, are being produced by the Indian machinery manufacturers today. And 70% is for the domestic market and 30% going for exports, adding a capacity within the country of about 150,000 tons per annum. Imported plants mostly from Europe, uh, on an average 3 to 4 plants each year, adding further capacity of 15,000 tons. So totally about 165,000 tons per annum is capacity is being added. But this pandemic has brought in a unique change, and we will find by the end of the year, the capacity addition will be much more because of the demand for films for laminates packaging. We've seen from July onwards, all our blown film machinery manufacturers have seen a huge uptrend in the demand to the extent that people come up to all of us and say, we want a blown film plant within 1 month, which is definitely not possible. But yes, there's a huge demand which has come up for blown film lines. Very interestingly, in the plastic processing machine segment, you have many Chinese machines coming into the country, whether it's injection molding or some extent sheet extrusion. But as far as blown film lines are concerned, the Indian machine manufacturers have really held their ground, and you do not find, or let me say, hardly any blown film line is coming into the country. very few blown film lines have come into the country. As I mentioned, in terms of technology, OEMs in India are mostly following the European American brands. And I would say the gap between those technologies and the Indian technologies today is not very high, because most of the automation which is used in these machines, whether it is gravimetric dosing or thickness control, are being imported from Europe. And surprisingly, at times, the cost of this kind of an automation goes up more than 50% of the cost of the machine. And many a times we tell people, especially the automation manufacturers, that we are not working for us, we are working more for you. But that's a fact of life. Yes, material conveying systems have been developed by Indian companies, but thickness control still continues to be imported, and they are big ticket items. And all instrumentation and controls indeed are complying to Industry 4 in terms of data collection. And Milind talked about operating a machine through an app on the phone. That is also available. We displayed the same. You see a machine in my background, which was displayed at the K, and we were operating it through an app. Now you have even up to 9-layer plants, 9-layer coming into the country, mostly European, but Indian companies are also ready with the 9-layer plants. Rakeshji mentioned about the PPTQ plants long time back, which we use for garment. I remember it was, I think, 7 or 8 years back, a company in Daman called Alpha Packaging was producing 2,000 tons per month of PPTQ film, all on machines made by us. But the prices of BOPP and CPP crashed. So that segment was wiped out, and now most of the PP is being used for bread packaging. Barrier films in India, unlike the world, India is largely not a meat-eating nation. We are a vegetarian nation. And that's one reason why the barrier films came into the country much later and primarily focusing on edible oils. And that is the reason why the technology development in barrier films was quite delayed. But now companies in India are giving both symmetrical and asymmetrical barrier layer films, and we at Raju have also supplied machines to South Africa. A new trend Milind mentioned about MDO. Yes, very promising trend, but today the investment levels are so high, and still people need to work on the wastage on the trims when the necking takes place. So that's quite a challenge just now, and I'm sure Indian market is ready for it, and couple of MDO plants have already coming into the country. That will definitely contribute to sustainability by coming in monolayer structures. Flatness enhancing has become a big subject today because high-end, you have converting machines requiring very high speeds. So flatness enhancer, it's a system which was introduced by European manufacturers, now also being offered by Raju. Another process which is becoming popular now is extrusion, coating, and lamination. A very unique combination of two technologies where you have extrusion and you have web handling coming in from the printing machine side. So we at Raju Engineers are giving these machines where you have basically for producing laminate for snack foods, or on one end, and very sophisticated going towards tube laminates. So you have simple structures like polyester, print, PE, CPP, adhesive, and PE film, and then going in for tandem. We're talking about films. Cast film is also already being talked about. Then sheet extrusion is quite a big segment in India. Sheets ranging in thickness from 100 microns and going up to 2 millimeters of polypropylene, polystyrene. And last 4-5 years has seen a big market for PET sheet using recycled bottle flakes. So both there is solid as well as foamed polystyrene, which is popular, primarily being used for disposable containers, blister packaging, thermoforming, cups and glasses, widths ranging from 600 mm to 2 meters, outputs ranging from 150 kg per hour, going to 2 layers, and also for barrier sheets with nylon and EVOH for food packaging containers. Milind did mention about melt blown fabric. Yes, Chinese were far ahead. On one end were Chinese, on the other end were European companies. Investment levels are very high. And India also, pandemic gave a great opportunity for melt-blown fabric, which is used in mask and for hygiene applications. And the challenging there part in melt-blown fabric is using PP material going up to even 1400 and 1500 MFIs. So this was just an overview of what is happening in the film, sheet, and melt-blown fabric segment in India. I can only say that India is the gap between Europeans and the advanced technologies and Indian technologies, all the Indian OEMs is not too wide right now. But yes, when it comes to investment levels, I always tell our customers that at the price levels you are looking at, there's a lot of differentiation, but not all products which you make need high investment levels. And that's where Indian OEMs, in my opinion, are giving very good solutions. Thanks very much. Over to you, Milind.
Yeah, thank you so much, Sunil, for your overall view of the Indian market and the technology segment. Rakesh Shah wants to make a quick comment before I invite Dr. Sundarshan for his speech. Rakesh, please go ahead with your comment. Please unmute yourself.
Milind, there is few questions, so will you now take or afterwards?
Yeah, you can go ahead, ask the questions.
For Sunil, one question, that is one Mr. Rao from Hyderabad. He is an entrepreneur. He wants to start with blown film line. So any advice you have to him?
Yeah. The first, not advice question, why do you want to get into blown films?
Yes.
Yeah, see, let me answer that question differently. It has got a good market, but you have to be very clear as to which market segment you want to look at. Blown film, as I mentioned, you can make shopping bags out of it and you can make barrier films out of it. So a lot depends upon what application you want to get into. We can take it offline and we can give you, we can guide you as to which segment you can look at. And obviously it depends on the investment levels you're looking at. Thank you.
Milind, there is another question. It is for you. One Mr. Magdoum. He is asking that which is the best sector in flexible packaging for investment?
My question answer will be very simple. Where the market segment.
Take that up as a consultancy assignment.
Okay, but just one line answer I will give is, it should be offline, but he should get into the segment where he is well connected.
Okay. And one question from our, we call grandfather of packaging industry, Mr. Vijay Sood. He is asking you a question. Thou multi-layer barrier film provides great opportunity to replacement of flexible laminates.
Yes. The barrier film segment is still quite virgin in India, I would say. The high-end, very special films which can replace the laminates are just being made. And fortunately or unfortunately, most of these limited players are now concentrating on exports, and their capacities are booked for export, where they make more money. As more capacities will be available, I'm sure it's a matter of time, Indian consumer will switch over to this barrier film, because the threshold values of barriers, what are required, is now broken with the new generation high barrier film. So it's a matter of time. There was some economics study was done, and it says that if Indian industry starts moving into this film, at least 80% more converters will have to come than the present capacity available. So almost doubling of market will happen. So scope exists, number of players are less.
Well, I just wanted to introduce Pankaj Bhai Shah, who's our IPI GC Council Vice Chairman. He has joined us today and he is now visible on the panel. So, hello Pankaj Bhai, namaskar to you and thank you very much for joining. Please unmute yourself. Unmute Pankaj Bhai, please.
Thank you, Rakesh Bhai, for the introduction, and I'm very happy that you have really made
arrange this program, which is very well knowledgeable and sharing the knowledge with the latest technology with our members. Thank you so much.
Thank you, Pankaj Bhai. Thank you very much for joining. Please stay with us. It's only a little bit left now.
Yes, yes, sir. Yes, sir.
Yes, I think there will be very good presentation ahead. Thank you.
Now I have the privilege of introducing you Dr. E Sundar. He's a very qualified polymer scientist, I would say, with a PhD and doctorate. He passed from UDCT. He has 26 years of extensive experience in Reliance Industries Product Application Center. He has handled various senior positions and various developmental projects for raw material additives and master batches. So today he will be speaking on the subject of impact of developments in polymers and additives and modifiers on film production. We are very keen to now hear him out. Over to you, Dr. Sundaresan.
Thank you, Milinji. We already have an excellent review of the developments of extrusion machinery and the technology over the last decades in India and abroad. Now, I will be talking about the developments in polymers, additives, and polymer structures, which are processed on these machines, which has already spoken to the Indian context. Now, since the multilayer sector is dominated with polyethylene as a raw material, I wanted to talk a little bit on the present status of polyethylene in the country. I will be making this presentation on PowerPoint and request Sandeep not to record because there are little bit of copyright slides which is coming into this presentation.
Question and answer session. What I will do is I will first go through all the questions that are sent to us through question and answer chat, this thing. Once I take the name, I would request Sunil that you should unmute the person whose name I have. So wants to ask, he can ask, sir. Is it okay with you, Sunil? You unmute yourself, please.
Sure, Milind.
Yeah. Now the first question is from N. Sivashankaran. Fortunately or unfortunately, he has asked the question to me. What are the barriers achieved already in multi-layer film, OTR, MVTR in 9-layer film? To the best of my understanding and practical experience, with 9-layer, people have achieved 0.1 OTR consistently, and WBTR is now manageable consistently less than 0.5. It still remains a challenge to match the metallized values, but it is coming closer to that. Are you okay with this answer, Shiva?
Okay. He's on mute unless you want me to unmute him.
Okay. Okay. Next question is from Madhav Chakravarti. Is nylon-based multi-layer film will be recyclable? My answer is yes. It is already being recycled. Next question is from Dinah. Sunil, you'll have to unmute because I'm not clear with the question. It says good day. Yeah. Is Dinah there? Then the question can be repeated.
No, I have unmuted, but probably the person does not want to. Okay. I think there is some question coming in. Are you there? I think the mic is not working. Milind, I think you can go over to the next one.
Okay. Next question is again from Sivashankaran. This question is for Dr. Sudarshan. Sudarshan, he says, what is the ideal percentage of LDP in a multi-layer extrusion film?
Ideal LDP is normally like if you're talking, it is again depend upon the structure want to use it. People use up to 30 to 40% of LDP in the 3 layers. The rest of will be metallocene and LLDP material.
Okay, thank you. Next question is from Atin Chowdhury. It is asked jointly to Sunil and myself. So Sunil will take the lead. The question says, for sustainability and packaging optimization, we require to shred intermediate layers like polyester, nylon, etc. in multi-layer packaging. The need is to increase mechanical strength of PE films to sustain stress like nitrogen flushing in liquid packaging. What additional support besides material the machine configuration can provide to reduce the gap?
Let me try. Let me try. A little bit complex. I think there was a discussion about MDO, and MDO would be the way forward to bring in more barrier into the film and also bring in more strength. And structures are being developed where you do not need to use either polyester or nylon. So the film structures are fully recyclable and also contributing to sustainability. Milind, you would like to add something to it?
Yeah. In terms of machine configuration, my experience is because I extensively work in nitrogen flushing segment for last more than 3 decades. The selection of screw geometry and its combination with die can dramatically alter the performance of the polyethylenes, and it adds up to the strength and mechanical as well as sealing strength. So there are a lot of parameters in the machine configuration which can help you in reducing this gap. It is a matter of detailed discussion which can be done separately on a different forum.
Milind, there is one Mr. Sitaram Narsingh who's raised his hand. If you allow, I will unmute.
Unmute. Yeah, go ahead. Let him ask the question.
Yeah. Mr. Sitaram? No. Next is there's Vishnu Priya UR who's raised her hand. Like to, if they would like to talk.
Yeah, allow them to ask the question. We are open.
I've unmuted them. No, I think probably they raised their hand by mistake, or they were giving a thumbs up to Milind, to you, Milind, probably. So anyway, you can carry on.
Okay. Next question is from Pratik Singh. He's a student in IIP. He says engineers are claiming to have achieved 90% biodegradable plastics, but some officials been saying it's just a marketing act. What is your stand? And if we have created a real green plastic, does it really solve the problem in a bigger picture? Now, ma'am, answer is very simple. First of all, unless the material biodegradable more than 95%, it is not classified as a biodegradable material. There are enough of such materials available in India. Not only that, 100% biodegradable and compostable films are being made in India. And I can say it authoritatively because I hold the patent for it. So you can take my word that it exists. These kind of films are used. Sunil, you were saying something.
There's a question in the chat box. Agricultural mulching film is better 3-layer or 5-layer?
Well, it depends upon how you look at it. But if you see mechanically and the new international trends and benefits, 5-layer film is better. The next question is from Rajesh Doshi. He says, very much informative presentation, great insights of machinery and material equipment. Thanks to all, sir. Okay, we acknowledge your appreciation. Thank you so much for that. Now, besides that, I have a few questions to the panelists itself. I'll start with Dr. Sudarshan. In India, the only variety of polymers that are manufactured are just polyethylene. Now, this being such a large market, why other than conventional polyethylene material manufacturers are not setting up their shop in India?
See, if you're talking about like metallizine, we have already GAIL, which is in the production of metallizine polyethylene, and they already came with 2 production process. And see, today, if you look at the metallizine imports in this country, we have about 2.5 lakhs of metallizine which is coming. Now, to starting a totally a new plant for the metallizine, dedicated plant, I don't think how viable will be for a petrochemical company. Now, it is not the end of that. Now, today we have innovation technology existing with Reliance Industries, and um, our HMEL is also going to come in the future. So maybe they will also think about starting the metallurgy process. It's something, which I will not able to comment anything on that. But it's not the end of the story. We will be making only the conventional butane-based LLDP film.
Okay, thank you. My one question is to Sunil. Sunil, you said that there were technology partners in India for four leading manufacturers, and somehow that joint collaborations did not last long. Now, with changing market scenario, and if India has to adapt to this latest technologies, how we make these associations work again in India? What are your views?
I think we need to revisit see, because what has happened is at the time these partnerships were there, the market in India was not very big for, if I may say, high capital intensive machines. But the market now has come back. As I mentioned, there are now requirements for 400 kgs per hour, 1 ton per hour plants. So I think maybe we need to revisit them and invite them again to come to India. Um, People in Europe have always been very skeptical when sharing technologies with Indian companies, which is a fact. So I think we need to reinstill confidence in them and try to bring them back.
Okay, thank you. There is one question from Atin Chaudhary for Dr. Sudarshan. He says some nanoparticles pose serious migration threats for particle size in food packaging, and there is a question mark and restriction from some overseas brand. What is the way forward?
See, this is a totally a new subject which is under evaluation. And if
Hmm.
you look at the nanoparticles, what is used in the polymer film, they are
Hmm.
normally used in the barrier layers, either in the EVOH layer or in the PVDF layer. So these layers are not coming in contact with the food particles, food contamination. So I don't think it is any issue as on today, but it is still a developing stage.
Okay. There is one more question for you, Doctor, from Srikant Diwan. It says, with more and more layers with different materials added to the film structure, we are able to get better properties and or optimized thickness. But with this, is the end of life management getting affected?
It is a very difficult, and question to answer.
Hmm. Hmm.
See, the trend is to make more and more, the structure recyclable,
Hmm.
and some of the developments which is happening even in the tie layer, that they are recyclable. Now, when you have a metal, I mean, when you have a EVOH level or when you have a
Hmm.
nylon layer, the
Hmm.
percentage of those in the multi-layer is much lower, and I don't think
Hmm.
it is going to have any effect on the recyclability. I mean, there will be a
Okay.
technology to make this product as recyclable. Yes, this is going to be a big question. That is why
Hmm.
people are now trying to make, all polyethylene pouches for environmental friendly products.
Okay. Thank you. There is question from Shubham Lakra. He says, what is the second most polymer used in PE layer, multi-layer film after PE? Uh, well, it's a very tricky question because even if you say tie layer, it is a copolymer of PE. If you take EVOH, again, PE is involved in that. So it is very difficult to say which is the second most used polymer in PE. In general, I would say if you're talking of barrier, because non-PE will essentially lead to barrier film segment, then nylon and EVH are the two materials to watch for. Uh, Second question is, what machinery do you recommend for multi-layer film cycling? There are many machineries, but the specialist in this is an Italian company called Sorema. So you can contact Sorema for that. Okay, I think we don't have any more questions, so I will request Rakesh Shah to again do the closing ceremony. Okay, over to you.
Thank you very much, all panelists. This was a wonderful session. I think it was very well attended as well. I think we had the attendance reaching something like 120 people at some point in time, could be more. And I think this has been a very good collaborative project as well with IPI and KSF. I would like to thank all the participants for their keen interest and for their questions, which were quite incisive. And I think they have also helped to add to what was left out in our discussions and to enhance our understanding on the whole of all the subjects which have been discussed. So thank you very much. We would call this webinar to a close. And I wish you all the best, good health, be safe, and take care. Thank you. Bye-bye.
Okay.
Anjumji, would you like to pose a word of thanks, Anjumji?
Yes, thank you, sir. I would first like to thank Shri Hariram Thakurji for sparing his time and attending the webinar organized by Knowledge Sharing Forum and Delhi Chapter IPI and enlightening us about the activities of IPI. I would also like to thank Vice Chairman Pankaj Shah for his presence. At the same time, I would like to thank Mr. Subodh Gupta for creating this forum, which is really very useful to all of us, and now sharing with the IPI. And today's program has been really great success. And Subodhji, thank you. You had a good recovery today, so that's another good news that he has recovered well. And I would like to thank all the panelists, Mr. Rakesh Shah, the chairman also of Delhi Chapter IPI, Mr. Milind Bole, Mr. Sunil Jain, Dr. Sundaresan, for giving us such a vast knowledge about all the aspects of flexible packaging, the machinery, the materials. And I would also like to thank Mr. Mihir Banerjee for organizing this, putting the initial thought for organizing this kind of seminar, webinar for us. I would also like to thank the team at headquarters of IPI for giving this technical support, especially Sandeep Shinde and his team. And thank you very much to all the participants for keen interest shown in this and making it a huge success. Thank you all.
Anjumji, Subodhji has managed to join in. I would request Subodhji to say a couple of words because this was wholly his initiative.
Yes, yes.
Sunil bhai, so thank you very much. It was not required. I think Anjum bhai and you guys have had a beautiful seminar today. I'm sorry my voice is a little off. I had been a little under a bout of a sore throat and a fever and a scare generally, which is in today's time. Fortunately, all the reports were negative. So one thing is good for that. Anyway, I think I must tell you, Anjum has given me the credit for Knowledge Share Forum. That is not what it is. This was created, Rakesh bhai, Dada, Anjumai and I, we were talking almost every day during the lockdown. And one of the days in April, we decided that why don't we, meet all our friends, especially the North. Hamara group which we normally call is a North Packing Group and the Plastic Group. So we just started it, and Sunil bhai was the first among to join. And the idea initially was just to meet and Shiva, I'll just call you back. The idea was just to meet everyone and हाल चाल पूछने कि भाई सब ठीक चल रहा है नहीं चल रहा है, and this just started. And we just one day started and saying that why don't, while all of us are under lockdown, why don't we start having some nice eminent speakers and add to our knowledge. And if anything that we can all do while sitting at home in today's time is some upskilling. So I think that was the idea, and it has really come up very well for all of us. Of course, we have a small group, which is about 30-40 people. Lately, some of them have not been coming, maybe busy with the work and all. But we've been fortunate enough so far to have a very good, speakers and subjects, and we are trying to improve every time. So thank you very much. Thank you all. It was a great day. I'm sorry I joined you a little late. Thank you.
Thank you.
Okay.
Bye-bye.
Okay.
Thank you very much, sir.
Thank you.
Thank you.